In this video, we're going to continue looking at shapes and geometry, but move on to the topic of volume and capacity of 3D solids. We will start with understanding what volume and capacity are and the difference between them, move on to how we can calculate the volume of various different types of prisms, and then work on some examples of how to solve specific questions in relation to those types of prisms. We'll finish up with a summary and review of all the things we've gone through today. What is volume? Volume is the amount of 3D space that an object takes up. It's measured in cubed units, so centimeters cubed, meters cubed, kilometers cubed. Capacity is the amount of liquid a container can hold, so liters, milliliters, etc. The difference between them can be illustrated if we consider the two beakers above. Say we have two identical beakers with an equal amount of volume, and I take one of these beakers and make the glass slightly thicker. The capacity hasn't changed. It can still fill up exactly the same amount of liquid, but the volume has changed because now the object is thicker and taking up a much larger space. In order to solve for the volume of a rectangular prism, we need to find the area of its end and multiply it by the height of the prism. In this case, the area of the end is going to be this rectangle here, but we could equally use the rectangle on the other end. It wouldn't make a difference. So solve for the area of the end by doing length times breadth or length times width, and then multiply that again by the height or the height of the prism. In order to solve for the volume of a triangular prism, we need to determine the area of the end and multiply it by the height of the prism. When we're talking about the height of the prism, be careful not to confuse it with the perpendicular height of the triangle that we need to use to solve for the area of the end, this triangle here. So be sure to distinguish between the length of the prism or the height of the prism and the perpendicular height of the triangle. We are now going to look at an example of how to solve for the volume of a rectangular prism. The following prism with these dimensions can be solved for the volume when we remember the steps that we outlined in the previous parts of the video. First, solve for the area of the end and then multiply it by the height of the prism. The working is as follows. In order to solve for the volume of this rectangular prism, we need to calculate the end shape's area and then multiply it by the height. So the volume is going to be equal to the area of the end shape multiplied by the height or length of the shape. So in this particular example, we have the end shape is going to be a rectangle, and the rectangle has the dimensions 4 meters by 5 meters. So the area of the end shape is going to be equal to 5 times 4, which is going to be equal to 20 meters squared. Now we have that, we can calculate the volume, as the volume is going to be equal to the area at the end, which is equal to 20 meters squared, multiplied by the height or the length of the prism. So in our rectangular prism, we have our end shape, which is here, and this is our height here. This is our height or our length here, which was 6 meters. So our volume is going to be equal to 20 meters times 20 meters squared times 6 meters, which is going to be equal to 120 meters cubed. Make sure that you write cubed because we are measuring volume. Now we will look at another example of how to solve for the volume of a rectangular prism. This prism with these dimensions can be solved for using the processes in the previous example. So if you feel comfortable, please pause the video and give this an attempt yourself before looking at the work solution later in the video. To find the volume of this rectangular prism, we're going to use our generalized formula again, which is that volume is equal to the area of the end shape multiplied by the height of the prism. Now if we look at this particular prism, the end shape is a rectangle, and the dimensions of the rectangle are 8 meters on the base by 4 meters high. So the area of the end shape is equal to 4 times 8, which is equal to 32 meters squared. Now the volume is going to be equal to 32 meters squared multiplied by the height. And if we look at our rectangular prism, well, we can see, if we do a quick diagram, that our height is going to be this side here. Height, which is going to be equal to 22 meters. So our volume is going to be equal to 32 multiplied by 22 meters, which is equal to 704 meters cubed. We will now look at an example of how to solve for the volume of a triangular prism. A triangular prism like this one here has a few key dimensions that need to be pointed out. We have the base of the triangle and we have the perpendicular height of the triangle indicated by the white arrow, and we have the height of the prism. Please be sure to specify in your working which one of these dimensions is the height of the prism or length of the prism and which one is the perpendicular height of the triangle. To find the volume of a triangular prism, it's very similar to finding the volume of a rectangular prism. The volume is still going to be equal to, the area of the end shape multiplied by the height. Now, for a triangular prism, the way we would usually refer to height for finding the area of a triangle is the perpendicular height. But for this particular question, we're going to say that perpendicular height is equal to p. We're going to give it the designation of p as its variable. So the area of the end shape is a triangle. And it's a triangle that has a perpendicular height of 3 centimeters and a base of 4 centimeters. So we all remember the area of a triangle formula. Well, that's going to be equal to half times base times perpendicular height. But in order to avoid confusing the height of the prism and the height of the perpendicular height of the triangle, we're going to call perpendicular height our variable above p. So this is going to be equal to 1 over 2 times 4 times 3. and that is equal to 6 centimeters squared. So our volume is going to be equal to 6 centimeters squared multiplied by the height. And if we look at our triangular prism, this here is our height, and that is equal to 6 centimeters. So this times 6 centimeters, and that equals 36 centimeters cubed for our volume. Now we'll look at another example of how to solve for the volume of a triangular prism. This example uses the exact same processes as the one before, so please pause the video and give the problem a go before moving on to see the worked solution. In order to solve for this particular triangular prism's volume, we need to solve our general formula for finding the volume of a prism. So volume is equal to the area of the end shape multiplied by the height. And our end shape is a triangle with perpendicular height. Well, the perpendicular height is equal to 18 centimeters. And the base is equal to 25 centimeters. So the area of the end shape is equal to, well, the area of a triangle, which is 1/2 times base times perpendicular height. But in order to avoid confusion between the height of the prism and the perpendicular height of our end shape, we're going to call our perpendicular height P. So this is going to be equal to 1/2 times 25 times 18. And that is equal to 225 centimeters squared. Alright, now that we solved for the end shape, we just need to plug that into our equation for the volume and solve for the height. The volume is going to be equal to 225 centimeters squared multiplied by the height. And if we look at our triangular prism, our height, or our length here, our height is equal to 36 centimeters. So volume is going to be equal to 225 centimeters squared multiplied by 36 centimeters. And that is equal to 8,100 centimeters cubed. In this video, we looked at finding the volume of different types of prisms. One was a rectangular prism and the other was a triangular prism. In order to find the volume of different 3D solids, we need to apply the general rule that we multiply the end shape's area by the length of the prism. We also need to realize that there can be some confusing terminology between perpendicular height and the height of the prism, so be sure to take care when you're determining the volume of 3D solids. Thank you for watching this video. Please take some time to practice the skills you learnt in today's lesson and make sure you have them fully understood before moving on.